Hello, welcome to your pre-lesson video on week 3.1 linear equation in two variables. All right, so we need to cover series and sequences when we're answering the ACT and SAT math questions. So we'll get into a little bit of this, and then there will be more practice questions in the deep dive lesson as well as your homework and quiz. But anyways, the difference between arithmetic and geometric series is that with arithmetic sequence, it is a plus or minus difference, whereas with a geometric series, it's a multiplied or dividing difference. And we'll get into how to find out what those two are in a second. But anyways, with an arithmetic sequence, in order to find the end term, we would need to use this formula, which is an equals to a plus d times n minus 1, with an being the end term that we're trying to find. A is the first term that we are normally given. D is the difference in the sequence, and n is the term number that we are trying to find. So if let's say we're trying to find the 8th term, right? So that means our term number is going to be 8. So we'll plug in 8 right over here. All right. Now along those lines, sometimes they would also ask us to find the sum of the series. Okay. So we would need to use this formula, which is Sn equals to n over 2 times 2a plus d times n minus 1. All right, Sn here will be sum of first n number of terms. Again, n, as we know, would be the number of terms that we're adding. Right, so that means if we're trying to find the sum of the first 8 terms in the series, we will plug in 8 here. Right, and then some of the series will be like first term plus second term plus third term plus fourth term plus fifth term plus sixth term plus seventh term plus eighth term is what it means. Again, a here is the first term, and d is the difference again. All right. Now, in order to find the difference, what we need to do is take the number after and subtract it with the number before. So for example, let's say we are given the series 2, 4, 6, 8, 10, and blah, 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 blah. So if we want to find a difference here, let's say I am going to take, let's see, let me switch colors. I'm going to take this number and this number. And what I'm going to do here now is 6 minus 4 equals 2, which means my difference is 2. And that's what I mean by difference. In arithmetic sequence, you're going to take the number after and subtract it with the number before, right? So sometimes even a series could be like 10, 8, 6, 4, 2, 0, negative 2, and so on. That means if you were to find a difference, you would take like 8 minus 10, which would give you a difference of negative 2. All right, and that's how we would solve arithmetic sequences. And now with geometric sequences, like I say, the difference, or in this case, we actually use the term ratio, is multiplying or dividing. All right, so now to find the end term of a geometric sequence, we would need to use this formula, which is an equals to a times r to the power of n minus 1. Again, a here is the end term. This a is the first term. R is our ratio, and n is our term number, right? So that means if we're trying to find the 7th term, we would plug in 7 to where n is. Okay, now to find the sum, we would need to use this formula to find the sum of a geometric sequence. All right, so it'll be Sn equals to a times 1 minus r to the power of n divided by 1 minus r. And the big thing here is that r cannot equal to 1. Because if you plug in 1 here, you'll be dividing by 0, which is mathematically impossible. All right. And again, here, a would be your first term, Sn would be the sum of the first n number of terms in your sequence, and r is your ratio. All right. Same thing, n is also your term number, or the number of terms that you're adding in the sequence. Now, to find the ratio, what you would need to do is take the number after and divide it by number before. And so what that is, it's like, say, let's go 8, 4, 2, 1, half, and so on, right? So if I want to find my ratio, I am first going to let's take 4 and 8. Since 4 is after, we're going to do, so r equals to 4 over 8, which would equal to half. So that means our ratio for this geometric sequence is half. Now there's also the other side, right? Where it's like, say, we have 3, 9, 27, 81, and so on. And now let's take 9 and 3. So we'll get 9 divided by 3 equals to 3, and that will be our ratio. So as you can see, with r, if it's a fraction, that means it should be getting smaller, and if it's a whole number like this, it should be getting bigger. So that's a tip to think about and remember when you're doing geometric sequences. All right. Now, the next thing that we have is very important, especially in linear equations, which is a slope of a line and how they look. All right. So very briefly, if it looks like it's going uphill, it's a positive slope. If it looks like it's going downhill, it is a negative slope. If it's a flat line like this, that means your slope is 0. And if your slope is just a vertical line like that, means, well, you don't have a slope. It does not exist. All right, so that's just a key thing to remember. Now, when you're writing equations, it's really important to remember the slope formula, which is given by m equals to y2 minus y1 divided by x2 minus x1. All right. And another way to look at that is rise over run. All right. So let's say we're given the points 3, 9, and let's see, negative 5, 7. I'm going to designate these two as my x1 and y1, and these two as my x2 and y2. Now, when I am plugging them into the formula, I want to make sure that they're paired up. So that means the coordinates should be on top of each other, right? So that means if I'm going to plug in 7 over here, negative 5 should be at the bottom here. If I'm going to plug in 9 here, 3 should be here. I can't have it like where 7 is here, but then 3 is at the bottom, because those are not the pairs of points. They're not together. And if you were to do that, your answer will come out wrong. So make sure when you're putting it in the formula, the pairs of points are stacked on top of each other. All right. So now once that we have labeled, let's write out our equation. So we have 7 minus 9 divided by negative 5 minus 3. And that's going to give us negative 2 over 8. We'll simplify that. I mean negative 2 divided by negative 8, and then that will give us 1 over 4. And this is going to be a positive slope because it is a positive number, right? And so what this also tells us is that for every 1 unit up, it goes 4 units left, essentially. And that's what I mean by rise and run, right? So the number on top will be your rise. So it rises by 1 because it's a positive 1. And it runs to the, oops, did I say left? My bad. I meant to say right here. And because it's a positive 4, right? That means it will run to the right 4 units. Now, if it was a negative number, then we would say the opposite, right? So it'll be like 1 unit down, it goes 4 unit right, and that kind of stuff. So it really depends on how your slope is looking. But that's how you would find the slope, is by using this formula. So remember it because it's very important. All right, now with slope-intercept form, so this is one way to write your linear equations, and it's the most common form that appears in questions. So it's really, really helpful to remember y equals mx plus b, right? So y here is the y coordinate of the point given, or of the point on the line. M is your slope. X is the x coordinate of the point on the line. And B is your y-intercept. All right, so these are just really, really helpful to remember, so make sure you do. Then the next thing we have is converting slope-intercept form and graphing. So as you can see, this is not in slope-intercept form yet, because we want it as y equals mx plus b. All right, so now in order to do that, I am going to, remember we want it in this in the end. I'm going to first write down the equation that we're given. So we want y to be by itself. So let's get rid of 2x first. So we're going to subtract it from both sides of the equation. And that's going to give us 3y equals to negative 2. Let's see. Let's erase that real quick. We're going to get 6 minus 2x. I'm going to divide by 3 because I want y by itself, right? So we have y equals to 2 minus 2 over 3x. And then, remember, this is already correct, but if you want to see it easier, or if you're in a hurry and stuff, you can also rearrange it. So it's y equals negative 2 over 3x plus 2. And then this tells us from here, right? So that means we know that this is the m and this is the b. So our m is going to be negative 2 over 3 and our b is going to be 2. All right. And then if we were to plot that, graph that on a graph, right? Make sure you label your axis, very important. We would know it's like 1, 2, 3, 4, b0, negative 1, negative 2, negative 3. Quickly just draw this. Ooh. All right. Now we were to plot it, we instantly already know what one point is, which is going to be 0, 2, because that's where our y-intercept is going to be. All right. And then from here, because I know the slope is negative 2 over 3, that means I can go 2 units down and then 3 units to the right. So then it will end up here. That means my straight line, hopefully it's straight, will be passing from there to there. And then that will be my line. Really helpful also, don't forget to write the equation, which is y equals negative 2, 3x plus 2. All right, and that's how you would graph a linear equation. It's like I say, it's really helpful with slope-intercept form because one, you're technically already given a point with the y-intercept, and then you know how much to move it with the slope that you're given. All right, if you have any questions, bring it to your deep dive lesson. Now the next thing that we have is writing equation of lines using tables. So if you're given points on a table, make sure that we pair them up correctly. First thing we would need to do, right, is we need to find a slope. So I'm going to take these these points. All right, so I am going to have -4 minus 6 divided by 24 minus 9. That's going to give me -10 over 15, which after we simplify is again going to be -2 over 3. All right, from here we can then plug it in into y equals -2 over 3x plus b. We don't know what b is, and we're about to find that. What we need to do in order to find b is to take any of the points in this table and plug them in into y and x. But make sure you plug it in as a pair. So let's say I want to take this point, right? So I'm going to take this point and put them here, right? So now my equation is going to look like 14 equals -2 over 3 times -3 plus b. We're going to do -2 times 3, which gives us, hold on, which is going to give us -2. Actually, no, that's going to be a +2. Oops, daisies. There we go. So that's going to give us 2 plus b. All right. Want to isolate b, so we are going to subtract 2 from both sides of the equation, and b is going to be 12. Therefore, our equation, linear equation, is going to be written as y equals -2 over 3. Oh, that is definitely not a 3. All right, 2 over 3x plus 12. All right. Now the next thing that we have is writing equations of lines in standard form. As you can see, this is the format for writing in standard form. You could also write it as ax plus by minus c equals 0, and that's fine. Either or is fine for standard form. All right, so we'll get straight to the bottom. So as you can see, this is what we call point form. Point slope form, and we are actually going to be learning that in a second. But first, we are going to convert this into standard form. So in order to do that, we're going to first distribute the parentheses. So we have y plus 5, because we didn't do anything to it, equals to 7x minus 56. Going to add 5 on both sides and subtract 7x on both sides. From there, we get -7x plus y equals to -51. And so, sorry, there we go. We wouldn't be adding, my bad. We would be subtracting 5. There we go. So we get -61 here. And that will be, and then this will be our equation in standard form. All right. Like I said, the other way that you could also write it as -7x plus y plus 61 equals 0. And this would also be another way you could write it in standard form. All right. Now point slope form. So point slope form, as you can see, is given in this format. All right. So y1 is the y coordinate of a point that's on the line. Again, m we know is the slope, and x1 is the x coordinate of a point on the line. All right, so when we want to write it in point slope form, we will write it in this format. Now, as you can see, this equation is in slope-intercept form, and now we're going to transform it into point slope form. So in order to first do that, we need to find a point that's on the line. So I'm just going to pick any random number. I'm going to pick my x as 10. So I'm just going to write in coordinates first to keep track. So now I'm going to replace x with 10. So we have y equals -3 over 5 times 10 plus 3. That's going to give us y equals -6 plus 3. Y would then equal to 3. Alright, so that means I know a point on the line is going to be 10, negative 3. And so that means we know that x1 is going to be 10, y1 is going to be negative 3, and my slope is going to be negative 3 over 5. And from there, I would just plug it in into the equation, right, which is y minus y1 equals to m times x minus x1. Just plug it all in. So this is what we're going to get. And then since here is negative times negative, we're just going to open the parentheses, which would then finally give us y plus 3 equals to negative 3 over 5 times x minus 10. And then this would be our equation in point slope form. All right. There we go. All right, the next thing that we have is writing equation using 2 points given. So if we are given 2 points, negative 1 and negative 2, and for 5, we can take either one as x1, y2. Oh, x1, y1, x2, y2, right? So in slope intercept form, this is how I would write it. First, I would need to find my slope. So I'm just going to do this real quick since we should have learned this before. And then in the end, that is going to give us 7 over 5. So that means y equals 7 over 5x plus b. Take any of the points, plug it in here. So we have 5. So I'm going to take this point. So we have 5 equals to 7 over 5 times 4 plus b. 5 equals to 28 over 5 plus b. b would then equal to negative 3 over 5. And so that means my equation is going to be written as y equals 7 over 5x minus 3 over 5 in a slope-intercept form. Now for point slope form, I'm already found the slope and I have a point, so I can just chuck it in real quick. So I'm going to use the 4 over 5 point again. So I will then get y minus 5 equals to 7 over 5 times x minus 4. And that will be my equation in point slope form. You could also use negative 1, negative 2 in place of 5 and 4. That's completely fine. All right. And then in standard form, we can just rearrange this to then give us this. So I'm just going to take, actually I'm going to take point slope form to show you how it's done. So from here we have y minus 5 equals to 7 over 5 times this. Distribute the parentheses to give us all this. And in a second you will actually see that we get back our slope-intercept form, right? So we'll get y equals 7 over 5, x minus 3 over 5. I'm going to bring x to the other side by subtracting it. So we get negative 7 over 5x plus y equals negative 3 over 5. Because they're in fractions, we might as well get rid of the fractions by multiplying the entire thing by 5. And so then that's going to give us negative 7x plus 5y equals negative 3. And that will be our equation. All right. Now, parallel lines. Parallel lines means that the slope is same. All right, so let's say we're given y equals 3x plus 7. Or more specifically, normally instructions are like, find the equation of the parallel line, find the equation of the line that is parallel to y equals 3x plus 7, and it passes through the point 2, negative 1, all right? Because they are parallel, and we know the slopes are the same, that means we instantly know that their slope is going to be 3. right? So it means we can write our parallel line as y equals 3x plus b. We don't know what b is, but we're going to find out by plugging in this in. So then we're going to get -1 equals 3 times 2 plus b. B would equal to -7. Therefore, our equation of parallel line is y equals 3x minus 7. All right. Now with perpendicular line, it means our slope is a negative reciprocal. There we go. We can use this formula to find it, which is m1 times m2 equals to -1. Say we're given the same equation again. So y equals 3x plus 7 passes through 9, 12. All right. So find the equation of the perpendicular line that is perpendicular to y equals 3x plus 7 and passes through the point 9, 12. So because we know m1 is 3, we're going to plug that in into the formula now. M2 equals -1. Divide everything by 3. So that means m2 is going to be -1 over 3. So it means now we can write our perpendicular line as y equals -1 over 3x plus b. We're going to find b by plugging this in. So 12 equals to -1 over 3 times 9 plus b. B is going to equal to 15. Therefore, our equation of the perpendicular line is going to be y equals -1 over 3x plus 15. All right. If you have any questions about this, leave it in your, bring it to your deep dive lesson. All right. Next thing we have is direct variation. So direct variation is normally given in the formula as y equals kx, where k is your constant of proportionality. There we go. And some keywords that the question normally has when you're answering these questions is it will say like it varies directly. It is directly proportional. All right. So if you look at the question, example question below, it's like if x equals 10 and y equals 20 follow a direct variation, right? So normally it's y equals kx. Find the constant of proportionality and the direct variation. So we know y is 20, k is, we don't know what k is, so we're trying to find an x is 10. Divide both sides by 10. So now we know that k is going to be 2. And our equation, our direct variation equation is going to be y equals 2x. All right, so it's very straightforward direct variation. Now, inverse variation is where you're going to be dividing it, essentially, is how you can say it. As you can see, the formula is going to be y equals k divided by x. K, again, is your constant of proportionality, so it's a constant number. It doesn't change. It's fixed. Keywords in questions you will see is like it varies inversely proportional. All right, so let's look at this example question. Suppose x and y are in an inverse proportion such that when x equals 15, then y equals 4. First, find the constant of proportionality and the inverse variation equation, then find the value of y when x equals 20. So we know y equals k over x. Y is 4 when x is 15, so we can just substitute that all in. Multiply both sides by 15, and that's going to give us k equals 60. That means our constant proportionality is going to be 60, and our inverse variation equation is going to be y equals 60 over k. Now we're going to use this to find the value of y when x is 20, so we're just going to plug all of that in. And so y would equal to 3 when x is 20. All right. All right. Now the very last two things that we have besides this, actually, so we have combination of direct and inverse variation. So joint variation is when we have two direct variations in a row, and it's normally worded as like y is varied jointly by x and z, which means y equals k, which is constant proportionality, times x times z. All right, so very straightforward. Now, combined variation would have both direct and inverse variation in one equation. And so how this will look like, if x varies directly as y and inversely as z, right? So that means your equation is going to look like this. And x is 10 when y is 5 and z is 3. For what value of z will x equals 3 and y equals 4? Okay, so as you can see, the first thing I need to find is k, right? The concept of proportionality. So I'm going to multiply both sides by the reciprocal, which is going to be 3 over 5, which will then give me k as 6. So that means my equation is going to be x equals to 6y over z. I want to find what z is, so I'm going to plug in 3 into x, 6, y with 4, and z leave at the bottom. So it's going to be 3 equals 6 times 4 divided by z. All right. Multiply both sides by z. It's going to give us 3z equals 24. I want z by itself, so divide everything by 3. So z equals to 8. And that will be the answer. All right. If you have any questions about this, bring it to your deep dive lesson. Now, the next thing that we have, very, very last thing, I swear, is this word problem that we're going to see how it affects, how it uses like variation. All right. So Designer Dolls found that its number of dress-up dolls sold N varies directly with their advertising budget A and inversely proportional with the price of each doll P. All right, so this is going to be our equation. When $54,000 was spent on advertising and the price of the doll is 90, then 9,600 units are sold. All right, so that means N is going to be 9,600, A is going to be 54,000, and P is going to be 90. From there, we are going to find the constant of proportionality, and after calculating everything, that's going to give us 16, right? So that means our equation is going to be N equals to 16A divided by P. Now, the next thing it wants us to find, or the thing it actually does want us to find, is determine the number of dolls sold if the amount of advertising budget is increased to 144,000. All right, so that means P, the price of the dolls, did not change. So how that's going to look like in our equation is N equals 16 times 144,000 divided by 90. Plug that all in into the calculator. So that means our units sold is going to be $25,600. All right, and that will be the answer. Alrighty guys, and so this is the end of your pre-lesson video on linear equations in two variables. If you have any questions, bring it to your deep dive lessons. Alright, thanks for staying tuned. Have a good rest of your day.